Bismillahirrahmanirrahim. Assalamu alaikum and good morning to you all. Today I am Mahfuzur Rahman. I'm here to present about my demo 2 of my PS2. I have been supervised by Dr. Syed Hamid Hossein Madani. Now let's take a look at my project title. Securing integrity of big data in cloud computing using algebraic signature. Now let's move on to the contents of the presentation. Research objectives, dataset, research experiment, research results of the computational cost and the communication cost, and finally the storage cost on TPA. Now let's move on to the research objectives. The first part is already been shown in the demo 1, which is to select types of big data that is to be experimented using algebraic signature, creating algebraic signature on pieces of data involving video files, music files, medical records, email files, and PDF files. Then the second part, the half of it is already been shown in demo 1, and the second part will be shown in demo 2, which is to suggest a cost-effective remote data auditing approaches, algebraic signature for cloud computing data storage that minimize processing and connectivity costs on both the customer and the cloud server. And finally, this is to be shown in demo 2 to test the proposed method by employing significance analysis as testing in the simultaneous situation like cloud, Google Cloud Platform, infrastructure as a service. Now moving on to the dataset. For this research, I have used 5 types of dataset, which has been divided into the smaller size and large size. For the smaller size, which have the 1 MB and 50 MB for media files, medical files, email files, PDFs, and music files. For the largest dataset, the video files had 500 MB and 1000 MB. Now moving on to the research experiment. For the research experiment was done using Asus VivoBook Pro 15, which had a high performance Intel Core chip of Core i5 7th generation and had 16 GB RAM with a dedicated graphics card of 4 GB, and the programming language I have used is Python version 3.927, and the IDE was PyCharm, which was used to develop the experimental program for creating algebraic signature. On the next slide, we will see a small demo of how this program was used to create algebraic signatures, and we'll see how it can be used to show the integrity in the Google Cloud simulation. As you can see, this is the experimental program that I've created for creating algebraic signature. So let's run the program. Here, first of all, the customer will be required to select which type of storage they will be using. So for the customer, they will choose local. Then they will have to enter the file location in the local storage. So they need to choose the directory that the file is been located. Then they have to type in the file type. So for this one, this is medical file. I'll also state the name of the just state the name for the reference. So as you can see, the algebraic signature is this one. So let's copy it for our reference. And as you can see, the execution time has been stated too. So this is the Google Cloud Platform Service, and this bucket I have uploaded the files which I'll be using. And now let's move on to the program to see how it works. Run the program again. Now this will ask for the storage type. So this is cloud. Now it will ask for the file location. So let's go and take a look where I can find the file location. So there's the three dots. Here you can see copy. So this is the source, this is the directory of the file. I'll paste it here. So file type is medical file. Just the name for the reference. So as you can see, it gives me the same algebraic signature, which says that the file did not change, there was no change, so it is giving the same signature. But you can see there is an increase in time because it has been accessing the file from the cloud service, so it takes more time. Now let's see if there is a change in file. If there is a change in file, the algebraic signature changes or not. So we go to the file, make a change, simple change, this is 0.1. So let's make it 8 and save it. Now I need to delete this file and upload it again, the new one. Let's run the program again. Start with this cloud. So for the location, so similarly, we will go for this location. File type is medical file. Just name something. As you can see, there's a different algebraic signature for this file because there was change in the file. So as you can see, the different algebraic signature has been created. So from this, the TPA can know there was a change in the file and let the customer know that something happened in the file. So this is some small demo for my program. Now let's move on to the results of the program. Now moving on to the research results. The research results, the experiment is done on big data where 30 samples of 1 MB, 50 MB size of medical files, music files and PDF files and email files were taken. And similarly for the largest files, 500 MB and 1000 MB for video files. The purpose of the experiment is to see how much time, computational cost, and communications cost is needed in order to create algebraic signature for each file. Now moving on to the results of the computational cost. Digital file, music files, email files, and PDF files. These are for the 1 MB ones. As you can see, the blue represents the proposed model for the local side. This is for the customer side. And for the proposed model cloud side, on the orange one is for the cloud side. And you can also see the additional of the red and the green. This is for the reference. I will be comparing the Zhang and the Yan. These both are from the based on blockchain. So from the results, it can clearly be seen that the local side and the cloud side had a better performance than the blockchain ones. But for the email files, you can see that there is no comparison done. It was because the email files were too small to compare. Now moving on the comparison. As you can see here, the medical files on the local side had a 65% less computational cost than the yen ones and 75% from the Zeng ones. Similarly, the music files had 45% and 55% represent. And for the PDF files, there is 65% and 75%. Now moving on to the cloud side, the yen is the first one and the Zeng is the second one. For the medical files, there is 45% and on the Zeng one is 55% less than. For the music file, 35 and 45, and PDF is 55 and 65. Now moving on the results of the competition for 50 MB. As you can see that only 3 of them is taken. Email file was not taken because it was very small to take. So as you can see, as before, the, the proposed model is significantly has less computational cost than the Zhang one and the Yan one. This table represents the comparison for the 50 MB, where you can see that the medical files and the music files and PDF files on the local side had significantly less amount of computational cost, and also for the cloud side, the results are as shown. Result cost of computational cost for 500 MB. The video files were selected for this one. You can see the comparison was not done because these files were too big for them. From this we can see that the local side and the cloud side. The cloud side had a significant increase in computational cost, an average of 1.5 times bigger. This was because for the accessing from the cloud and the latency too. Similarly, for the 1000 MB2, we can see a similar result as before, where there is a significant increase, almost an average of 1.5 MB, 1.5 greater. Moving on to the results of computational cost. As you can see, there was no comparison done because in the Yang and Zen, there was no mention of computational cost. This is the computational cost for 1 MB. As you can see, as the file size increases, the computational cost also increases. Least computational cost. Now moving on to the computational cost of 450 MB. From here, you can see that as the file size increases, the computational cost also increases. From here, you can also see that the musical files had the least amount of computational cost. Now moving on to the storage cost of for TPA. For this one, the storage cost was on the file size. The file size represents the number of set of algebraic signature. The customer will create algebraic signature and put it in Excel file, which then file will be sent to the TPA. From that file, the TPA can then refer to that and select check if the with the cloud if the file is correctly being stored or not. From this graph, we can see that as the algebraic signature size increases, the file size also increases, and it is a proportional, and it increases proportionally. But you can also see that the when the set number increases as a high range of increase, like for like 200 algebraic signature, only a 15 KB size is being created. So a very less amount of cost is being uh, have been stored on the TPA. So the TPA have a very least amount of storage cost on itself. Thank you very much for listening to me. This was my presentation for my demo 2. Assalamu alaikum.